Good day, students. On this clip, we're going to be going over an example on how to graph hyperbolas in general form. Okay, so let's go ahead and write down the instruction for the example. So we're to um, express the given equation of a conic in standard form. Express it in standard form. Identify the conic, or identify it. Find its properties. Then graph, label, and state the meaning of your solution. Okay, graph, label, and state the meaning of your solution. Okay, and state the meaning. All right, so let's go ahead and take a look at the question under consideration. Number one, we're dealing with the equation 9x squared minus 4y squared minus 54x minus 8y plus 41 equals 0. Okay? All right, so let's take a look at this conic. This we can conclude that it is the equation of a hyperbola. Well, how do we know that it is the equation of a hyperbola? Well, if we observe this equation carefully, we'll notice that we have two squares. The coefficients are different, and you have a minus in between the two squares. All right, so anytime you have two squares, different coefficients, and a minus in between them, that is automatically a hyperbola. Also, if the coefficients are the same, you're still going to have a hyperbola. All right, so the key identifying mark here is the fact that you have two squares and a minus in between. All right, so this is the general form of the equation of the conic. General form. Now, first task is to express it in standard form so we can find the properties with ease. All right, so to do that, we're going to reorganize our variables. We'll place the x's next to each other. So we're going to have 9x squared minus 54x, and then the y's next to each other, and that's going to yield minus 4y squared minus 8y. And this constant right here goes to the right side of the equation because constant's always on the right side of the equation of the standard form. So we subtract 41 from both sides. So it is going to be equal to negative 41. All right. Now that we have our variables reorganized, we're going to partition them into two worlds, the x world and the y world, and we're going to complete the square in each world. Okay. So before we complete the square, you notice that we have a coefficient in front of the squares. Now that's a problem. To address that, we have to factor out that coefficient so we can have x squared alone and y squared alone. Okay, so this 9 has to be factored out. So if I factor out a 9, I'll be left with x squared minus 6x. And then on this y world, we have to be really careful because we have a minus right here. So we're going to factor out negative 4. Okay, so if I factor out negative 4 from negative 4y squared, it becomes a positive y squared. And if I factor out negative 4 from negative 8, I'll be left with positive 2y. Okay? So anytime you factor out a minus, the sign always changes. Okay? So that equals negative 41. Now I have two imperfect squares in this, two incomplete squares in this two quantities. So what we're going to do now is complete the square. Okay? Alright, so we have a for the x world and b for the x world right there. And then we have a for the y world and b for the y world right there also. Alright, so remember to complete the square, what you do is you add b over 2 squared, and that will create the perfect square trinomial. Now let's start with the x world. B of the x world is negative 6. So what do we do with that? We divide it by 2, and we square it. Okay, negative 3 squared equals 9. So 9 will create a perfect square trinomial in the x world. So let's go ahead and insert that. So we're going to have 9 times x squared minus 6x, and we're going to insert that 9 plus 9, close the parentheses. Now let's shift our attention to the y world. So in the y world, the b of y is positive 2. Okay? So what do we do with that? We divide it by 2, which equals 1, and then we square it, which equals 1. So this creates a perfect square trinomial in the y world. Alright, so let's go ahead and insert that. So we can have y squared plus 2y plus 1. Okay, plus 1. Alright, now what do we add on the right side of the equation is the question. So what we're going to do, we're going to add the product of these two numbers, 9 and positive 9, and then negative 4 and positive 1. Okay? Alright, so we have minus 41, which was what we had upstairs here, plus 9 times negative 9. Is it this negative 9 here? We'll multiply it with the 9 in front of the parentheses, minus 4 times positive 1, which is what we got when we did b over 2 squared in the y world. Okay? So this is what we're going to compute. Alright, so now let's go ahead and factor the left perfect square trinomials. You just bring down the 9 times. How do you factor a perfect square trinomial? You take the square root of the first term and the last term, and then you bring down the middle sign. Okay? So that yields x minus 3 quantity square. Okay, minus 4. Same process here. We're going to take the square root of the first term and the last term. You root the y square and you root the positive 1. And then you bring down the middle sign. Okay? So it's going to be y plus 1 quantity square. Okay? On the right side, if we work this out, minus 41 plus 81 minus 4 is going to yield 36. Now the standard form for the equation of a conic of a hyperbola requires that this quantity be equal to 1. So what we're going to do now is divide the entire equation by 36. Okay, so divide this by 36, divide this term by 36, and divide this term here by 36. Okay? Alright, 9 goes into itself once and then goes into 36 4 times. 4 goes here once, 4 goes into 36 9 times, and this divides evenly. 36 here is here 1, 36 goes here 1 also. Okay? So that yields x minus 3 squared over 4 minus y plus 1 squared over 9 equals 1. And you know what this is? This is the standard form of the equation of a hyperbola. Okay, standard form. How do we know that it's a hyperbola? Because we have two squares and a minus. That's sufficient. It doesn't matter if the denominators are the same or different. Alright, now that we have the standard form, we're going to identify it, find the properties, and graph. Alright, so what kind of conic is this? Conic? This is a hyperbola. Alright, now let's take a look at the properties. First thing we need is the center. You do the opposite of the number next to the x, which is negative 3, becomes positive. And the opposite of the number next to the y, positive 1, we have negative 1. Okay? Now next we need the central box. We're going to call it the dimension of central box. Okay, this central box will basically guide the construction of our hyperbola. Alright, so now our x-axis goes side to side and our y-axis goes up and down. Right? So what we're going to do is we're going to take the square root of 4. Square root of 4 is 2. Since 4 was under the x, we're going to go 2 units. There's going to be 2 units side to side from the center. So 2 units side to side. And then square root of 9 is 3. Since we got 9 from under the y, we're going to be going 3 units up and down from the center on the graph of the hyperbola. Now these directions will help create the midpoints of the sides or the medians of the side of our central box. All right, next thing we need is the C of the foci. C of the foci. So we're going to have C equals the square root of, we just add, remember I have a minus here, so you do the opposite, you just add the two denominators, 4 plus 9, which equals 13. So the square root of 13, let's write that again so it's clear. 4 plus 9 equals 13, root 13. Now, if you plug this into your calculator, this is approximately 3.6. So the question is, what direction do we graph the foci? Well, let's go ahead and label the sides first, the directions of the sides first. If we look at the side-to-side number, the number going side to side, that is a positive variable. The positive variable is the x. So since x is positive, it doesn't have a minus, it's going to be the real, we can call it the real transverse, or we can also call it the major axis, okay? Real transverse or major axis, because it is the positive one. Now the one going up and down is in the y direction. You notice this y in front of this negative in front of the y automatically makes this movement the conjugate axis. You can call it the imaginary conjugate, or the minor axis. Okay, so which direction does C go? Well, C goes in the direction of the real axis, okay, not the direction of the conjugate axis. So since it goes in the direction of the real axis, C is going to be going side to side. All right, now next thing we need to find is the eccentricity of our hyperbola. The eccentricity is going to be C of the foci divided by the real axis. All right, so divided by the real axis. So half of the real axis. So it is going to be C is root 13, and half of the real axis is 2, so it's going to be root 13 divided by 2. All right, so there goes your eccentricity. All right, now, all right, let's go ahead and graph our hyperbola. So the graph. Now, we notice that our center is 3, -1, which is centered in quadrant number 4. So we need to make our quadrant 4 sufficiently large to accommodate for that space, okay? So graph it like this. Okay, so let's go ahead and graph the center. The center is the first thing we go on the graph, which is 3, -1. So we go 1, 2, 3, and -1 on the y down here. All right, so this is your y-axis, and this is your x-axis. Okay. All right, now let's graph the midpoints of the medians of the sides of the central box. So we're going to go up and down 3 units, so 1, 2, 3, and then you're going to go down 1, 2, 3, and then side to side 2, 1, 2, and then 1, 2. All right, so there you have it. All right, so now that we've drawn the midpoints of the sides of the central box, now we're going to go ahead and draw the central box, okay? So our central box, we're going to draw using a dotted line since this is not part of the graph. All right, let's draw the central box using a dotted line. So you draw like this. So there goes your central box. All right. Now, next thing I like to draw is just the asymptote. The asymptote of the graph. I'm going to make that red. Actually, let's make it blue. All right, so the asymptote of the graph is the line that goes through the vertices of our central box. It goes through the vertices, okay? So that goes your first asymptote right there. a little bit longer. So that goes your first asymptote. And then the second asymptote goes through the second set of vertices. Dotted line again, let's make it blue. Alright, so we're going to draw it through the vertices like this. Alright, so there goes the second asymptote of our graph. Okay, now we have the asymptote in the central point. Now we're going to go ahead and draw the hyperbola. Okay, all these are just to set up the hyperbola for us so that we can draw it with ease. All right, so there we have that. Okay, so to draw the hyperbola, we just basically draw both of them starting from this midpoint here. So the orientation of our hyperbola, we were supposed to say that. Let's just say what the orientation is. The orientation of our hyperbola is going to be in the direction of the real axis. So the real axis is side to side. Our orientation of our hyperbola will also be side to side. So we're going to have one hyperbola on the left and one on the right. So you start graphing your hyperbola by graphing it from the central point right here. Okay, from the central point. Alright, so you draw it as best as you can from this midpoint right here. You go close to the asymptote and then you just curve out like that without touching it. And then the second one goes down close to the asymptote without touching it. And then you go to the side opposite it. Remember, our hyperbola goes side to side. Start from the midpoint. Go close to the asymptote and curve without touching it. Let's try that again. That looks a little bit crooked. It's close without touching it. And then you draw the next one. You go close to your asymptote without touching it, like that. Okay? So these two lines are basically our hyperbola. Alright, so let's go ahead and start labeling our points and parts of the graph. So to do that, to start off, I like to draw the axis so that when we have no problem graphing our foci. Okay, so let's go ahead and draw the axis. Remember, these axes are not part of the graph. So there goes the first axis, and there goes the second axis right there. All right. Okay, now let's go ahead and then label it. I'm going to start out by labeling the center. So this is the center right there. The center has the coordinates 3, negative 1. Okay. All right, and now we have the foci. Let's graph the foci. For the foci, we're supposed to go 3.6 units to the left and to the right. Okay, so we're going to go 1, 2, 3.6, somewhere here for the first one, and then the next one 1, 2, 3.6, somewhere here. Okay, all right, so this point right here is focus 1. Focus 1. And we're moving in the, let's write that again, focus 1. We're moving in the left and right direction. So that means that it's just our x-coordinate that will change, all right? So when we go to the right 3.6 units from 3, it's going to end up in 6.6, negative 1. And then when we go to the left, 3.6 units, 1, 2, 3.6. We're going to end up with focus 2. Focus 2 has the coordinates negative 1.6, negative 1.6. Wait a minute. We went 1, 2, 3. Actually, it's negative 0.6. Negative 0.6, negative 1. All right. So negative 0.6. Negative 0.6, negative 1. All right, because if we subtract 3.6 from 3, we end up with negative 0.6. Okay, now next thing we're going to graph are the coordinates of our vertices. So let's go ahead and label that. We have, this is going to be our vertex 1. Vertex 1. to get vertex 1, we went 2 units to the right, so we just add 2 to the x-coordinate here, so it's going to be 5, comma, -1. And then this point right here, this is vertex 1, this point right here is vertex 2. So let's label that up here. This is vertex 2. To get that, we just go 2 units to the left from from 3. So if we go 2 units to the left, 1, 2, that's going to take us to +1. So vertex 2 is going to be +1, comma, -1. All right, now let's go ahead and label our axis. Now I'm going to color the real and imaginary axis. So let's start off by drawing the real axis and its length. So let's do that. I'm going to call the real axis. Let's call it. Let's make it red. All right. So the real axis is going to be red. All right. So let's go ahead and grab that. So there goes your real axis. It goes side to side, and then our imaginary axis or conjugate axis is going to be going up and down. Let's color that green. So this would be your, I shouldn't change it yet. Make that green. All right, so this would be your conjugate axis. All right. Okay, so let's go ahead and label the axis, our axis and your lengths. So we have this axis right here. This one is your, we can call it real or transverse, real or transverse axis. Transverse axis. And the length, we're going 2 units in both directions, so it's 4 units. 4 units long. Okay? Now the axis going up and down, that's your conjugate or imaginary axis. Let's go ahead and label it. So here we have our conjugate or imaginary axis. And how long is it? We went up and down. How many units did we go up and down? 3 units, so it's going to be 6 units long. All right, so that's 6 units. All right, now let's write down the equation of our axis lines. So this right here, this horizontal line is your real axis line. Real axis line is a line that contains the real axis. Real axis line is y equals the y coordinate of your center, which is -1. And this line up here is your imaginary axis line, or let's call it conjugate axis line. Conjugate axis line. And its equation is x equals the x coordinate of your center, which is 3. All right, so that's that. Now let's go ahead and label the equations of our asymptotes. So let's label these ones in blue. So we're gonna have asymptote 1 and asymptote 2. All right, so this one will be asymptote 1. Asymptote 1. Now to do this, we're going to be using the points loop form of the equation of the line. Let's write it on the side here, which is basically y minus y1 equals mx minus x1. That's the equation we're going to be using from algebra 1. All right, so let's do that here. So for this one, we're going to have y minus y1 is the y coordinate of your center. This is y1 right here, and this is x1. So y minus y1 is y minus minus 1 is going to be y plus 1. Equals the slope of this line is the rise over the run. So if we pick this point, going from this point right here to this point, we're going to rise 1, 2, 3, and run 1, 2. So the rise over run is 3 over 2. So it's going to be 3 over 2 times x minus x1. x1 is 3, x minus 3. All right, so there you have it. That's asymptote 1. All right. Now this one right here is going to be asymptote 2. Asymptote 2. Asymptote 2. So same procedure, y minus y1 equals mx. Mx minus x1 is basically the same equation with the opposite slope. Okay, so let's just do the whole procedure again. So we have y minus y1. Y1 is negative 1, so if we subtract negative 1 from if we subtract negative 1 from y, it's going to become the same thing as adding 1. So y plus 1 equals. Now, what's the rise over run for this line that's going down here? So if we start from this point right here to this point, we're going to fall 3, 1, 2, 3, and run 1, 2. So it's a negative rise. So since we have a negative rise or fall of 3, we have negative 3 and a run of 2 times x minus x1, x minus 3. If you compare these two equations, you see that they're both the same, only that this is the opposite of that, all right? So there you have it. Okay, now that we have our asymptotes, that's basically all the labeling that we have to do, so we just have to state the meaning of our result, okay? So meaning, using the definition of a hyperbola. Okay, so meaning, the locus of points, the locus, so you can say the set of all points, the locus of points on a plane, whose difference, remember for ellipse is sum, but in hyperbola is difference, whose difference of distances, whose difference of distances from two fixed points. What are the fixed points that we're measuring our differences of distance from? They are the foci, okay? From two fixed points, f1, which is 6.6, comma negative 1, and f2, which is negative 0.6, comma negative 1, whose difference of distances from two fixed points is constantly the length of the transverse axis, is constantly side to side 4, it's constantly 4, is the hyperbola with the equation, hyperbola with the equation, so we just simply restate the original equation that we had with the equation 9x squared minus 4y squared minus 54x minus 8y plus 41 equals 0. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. And do post a comment to let me know what you think about this clip. More clips can be found on mathclassserve.com. Thanks again for watching and have a wonderful day.